So working with our canvas that we have here, currently the canvas does not have a width or height. If I save this document and then preview this document in the web browser, we're not going to see a lot of anything. So we'll look here and go, well, there's not much going on. There's nothing to see because my canvas, while it exists with marginal width and height, it has no content, it has no color, it's inherently, by design, transparent. So canvases, I just put a piece of transparent glass on screen. You can see that. I can pull up my console. There's no error messages, so I haven't screwed anything up yet. There's just nothing to see yet. A common thing when we're beginning, we may want to apply a style to our canvas. So I might want to go border so something like this. And we'll see there now my canvas does show up on screen. It does have width and height to it, all but marginal in size. It looks about 100 by 200 pixels in dimensions. But we now see that it exists. What we can do with it is we can set the width and height of the canvas through CSS. But we can also set the width and height of the canvas through JavaScript. And we can set the width and height of the canvas directly in the markup on the canvas tag. So we have 3 places in which we can do it. There's always going to be a pro or con depending on what solution you choose. Often when you're doing a lot of animation or visual programming, you will want to have access to that width and height number. So you may even set a variable to it and then set the canvas's width and height to that variable in your document as well. So that would mean that we would be accessing it inside our script. Now we can go through with our script, and if we have the script in the head, then we're going to have the go and do the onload init, set up our init function and do all of that. Or if we want to just cut down on some of that extra clutter for right now, we can put the script at the end of our document after the markup so that then all of the elements are now in memory and we don't need to worry about whether they've loaded yet or not. So I'm going to do that just to clean up the code a little bit so I don't have as much extra stuff in it this morning. And with that, we can see now we're waiting on the script, so we can go var. So the first thing, if I want to access the canvas, I need to create a variable reference to it. And I can just call it C. I could call it canvas. I could do whatever makes me happy there. I'll just do C. And then we'll get it by its ID, which is one of the reasons why we attached an ID to the canvas in the beginning. So now we access that element. Now we can just do a c.width equals, and it accepts widths in pixel dimensions, but we don't have to supply our unit of measure. So we can just simply say if I wanted it to have a width of 600, I could have a height equals 400. And now if I refresh my page, we'll see that it is indeed showing up. I will encourage you to keep your console up and visible while you are working on your document, because JavaScript doesn't fail and broadcast messages, put out alert boxes and say, oh, I ran into a problem. It just fails, and unless you pull up the console, you don't realize it failed, so you'll just be staring at a blank or empty screen wondering, well, why is it not working? So if you just leave it up, then when you refresh your page and you see bright red in the console, you know that, oops, there's something you might need to address at that moment. So now we proved we can set the width and height of that. And if we know we're doing that, we could take the wrapper and we could give the wrapper a width. Give it its width of 600. Give it a margin of 20 pixels and auto. And then I have my canvas showing up in the middle of the screen so it looks a little bit prettier.
Why are you putting PN?
Getting this canvas to show something, display something, work with it, we've accessed the canvas object. We've said, set our variable c equal to the canvas object. We've given that canvas object width and height. And now we're pretty much done with the canvas object after one more line, because the canvas object, think of it as a shell. But we can't say, hey, canvas, go draw something, load this image, do this, do that. The canvas is like, I don't care. You can say what you want, I don't care. Because the canvas doesn't accept any of that information. What is required of you to do is you have to get the context of the canvas. So we use one more line and we'll say c dot get context (2D). But we have to set it as var. Now some people will write out context in its entirety and say it's equal to this. Other people will just call it CTX. Depends on how much you like to type. If you like to type a lot, you could write out the entire word context. The same way we could have used var canvas is equal to this, canvas width, canvas height. Var context is equal to the canvas.get context 2D. You can use the words kind of repetitively and in their entirety, but some people find that when they name their variable equal to the element they're getting by ID, and that ID matches the tag, that suddenly you lose track of, wait, what thing am I actually referring to when I use the word canvas in 3 places? So if we use context in multiple places, sometimes that gets hard to keep track of as well. So most resources that you will see referencing doing canvas programming either refer to it as C, or they write out the word canvas in its entirety. They refer to it as CTX, or they write out the word context in its entirety. I mean, neither one is better or worse than the other. The few extra characters that you're typing are not going to have any performance issue or file size issue. So it comes down to personal preference at that point. I'm going to probably do most of the demonstrations using CTX just to try to differentiate, because CTX really does look like a variable we've named because it's not a full word or a camel-cased word. So I'm going to reference it more in that regard. So this context is where we can say context, fill style, context, fill rect, context, clear rect, context, begin path, line to move. All of the drawing commands that we're going to issue to our canvas are done through the context. The context is what accepts the commands, not the canvas itself. The canvas is just the canvas is just the area where we get to paint, but the context is what can actually do the painting for us. So that's the distinction between those two. And you will notice where it says 2D, you may be wondering, is there a 3D? The answer is not yet, but there is Webgl, which does support full 3D on canvas drawing, and that's a whole separate area that we are not going to be getting into. But if you're excited about it, you can look up Canvas Webgl and see that there's all kinds of really cool libraries that people have created that allow you to do 3D animations and visualizations on the canvas through JavaScript. So it is there, and WebGL is hardware accelerated, so it uses the graphics card. It really smokes on modern browsers. So it's got some just really good performance available to it. So at this point, save, go over here, refresh my page. Notice I still have no error messages. I do encourage you to very regularly keep previewing or reloading your page in the web browser to find out if the console is telling you that you have a mistake in your code. The more lines of code you take with or type in without testing it in the browser, the greater the likelihood you're going to have a mistake that is harder and harder to track down. So add a little bit, refresh the page. Add a little bit, refresh the page, and do that on a consistent basis, and that's going to make things a little bit easier for you. So now what we can simply do is to draw a rectangle on this context. If I set up something like context.fillStyle equals, and now I'm going to specify a color, and the color I specify, we can do it using hex color naming. We can use it RGB or RGBA color conventions. So if I want to do my color that I'm filling this with using a hex color, I could do something like 0000FF, and then tell the context dot fill rect. This is how we can draw a rectangle. And now, oops, sorry, fill rect is like this. And fill rect, as you'll notice on your cheat sheet, it takes an X and a Y and a width and a height. So if I want this to fill at 100, 100, and to be 200 wide and 50 tall, so we can see that we set the fill color, and the fill color then, or style for the fill, will remain that color until it encounters an additional or new fill style command. So that color will stay in effect until somewhere else in your code references a new fill color or style. Save it, refresh, and you can see now it draws onto the canvas. It started drawing at 100 by 100. It drew 200 wide and 50 tall. The key thing to remember when you're working in Canvas is that it is a stateless environment, so that what I've drawn on this is effectively drawn and forgotten. So I drew this box, or I filled this rectangle. So if I have another command that says draw another rectangle, it's oblivious to that rectangle that was already there, unless I create an object. So if I create an object the way before break we created the dog object or the rectangle object, the circle object, and made those objects through code. If here, unless I create an object where I can now keep that object in memory, everything I draw into the canvas is, once it's drawn, it's there until I draw something else on top. It doesn't exist. It's not a drawn object that then can be drug around, moved, and repositioned in the same way that, say, in Flash, where when you make something, the object is a visual object inherently. Here, I dumped paint. In this case, I put blue paint onto my canvas. Now that blue paint is permanently attached to the canvas, and it will stay there until I put something else on top of it. And my document has no awareness that there's really any difference between the white pixels or the blue pixels. They're just changed color. That's it. So it's a stateless environment, which makes it a little bit different than some animation environments, but it's similar to processing's stateless environment, where every frame it's ignoring what was drawn previously, so you have to either clear the background or draw something over the top of it to replace what's there previously. So now I have a rectangle that's shown up on screen. If I want to draw a second rectangle, I can just say context fill rect, and then provide my positioning information of where I want it to be. So I could say put this one at 310 and then make it 23 pixels wide and 123 pixels long. Now if we do that, you'll see we get a second rectangle. So all it's doing is drawing those pixels on screen. There's no frame rate right now. It's not automatically looping through anything. All it does is draw. So these are immediate calls to the drawing canvas. We will actually have to construct a function and then set up a timing object, such as set interval, and have that loop through a series of, or cause a function to be called repeatedly if we desire to create a frame-based or time-based experience. Because right now, we're just drawing immediately to it, and that is it. So now we can draw two rectangles. If I want to draw a circle, the circle gets a little bit different. First off, I'm going to change my color at this point. So we'll change my fill style, and we'll make my circle. Now, RGB takes values of 0 to 255. RGBA takes values of 0 to 255. And the alpha is a value of 0 to 1. So it's the same as the RGBA of CSS, where it's 255, 255, 255, 1. And 0 is transparent, 1 is opaque. So if I want this to be transparent, I would do something like that. Now that sets my fill style. So even before I draw a circle, if I were to just put this here, you'll see, and now I'm going to just pull the X over on that one, and so we'll get it overlapping so we can verify that it is indeed. So we can see by the color overlap that it is a transparent red that it's filled it with. So that context will stay, or that fill style will stay with my context until I say become something new. Now drawing an arc, it takes a position information of where it's going to be, an X and a Y. And then it takes a radius in pixels of how big it's going to be. And after that, it takes a starting angle and an ending angle. So what the arc does, there is no draw circle, draw ellipse. So what it's doing is it's drawing around a circle. So it draws a portion of a circle, and you can choose whether you want to go clockwise or anti-clockwise. If that value is a true or false, a Boolean that you would put in. So if you say true, then it will draw counterclockwise. If you say false for that final parameter, then it will be drawing an arc in a clockwise manner. And then we can say where you want the starting position to begin. And then you get to say how far you want to go. Now the unit of measure that it takes is not degrees, but it's going to be accepting radians. So then we could look at something like, actually we'll just go math.pi. So we're just going to go math.pi radians just to see what happens, and then finally say false. So to draw the circle, we've defined the circle, but we don't get to see anything until we also say we have to tell the context to begin our path. And some of you will be realizing that, gee, could we just use images and this would be easier because I can just stick images in and don't have to use all these geometric drawing things. The advantage, though, of using the geometric drawing, of using the drawing API on the canvas, though, is going to be performance. Because you could draw thousands and thousands and thousands of Canvas API objects, rectangles and arcs and lines and Bezier curves and all these other sorts of things. And you don't have to download any files to do so, so you can get some pretty wicked performance out of it. More so than loading bitmap images into it and animating those across the screen.
I could get the circle without the beginning. That's why you need text.
Yeah. So math.pi. So 2 pi r is the circumference of a circle. So right now we have 1 pi, which is why we get half of a circle. Now there is, if you don't want to have to think about 2 pi r and okay, now what's a quarter circle? What's even, if you're used to thinking about circles and rotation in terms of degrees, 360 degrees in a circle, and you can compute that easy in your head, there is a shortcut that you can use, which is you will say math.pi divided by 180 times whatever degree amount you want. So that will give you the math.pi divided by 180 times degrees converts that degree amount to a unit of measure in radians. So if you want to do it that way, so if we wanted to say start at 15 degrees and go to 87 degrees, because that makes sense to your brain, you can see that you can do that. So if you wanted to do a full circle, then you could go 0 and 360, and then that gives you the full circle as part of it. Now, if we use the begin path, we can also use context.stroke_style, which is now going to assign the color to it. And we're also able to, besides using color designations of hex, of RGB, RGBA, we can also sometimes, if we want, just use the simple names that CSS recognizes. So all these, the color information that we're able to use is the same kind of naming schemes that we follow when we're doing the CSS. So we can use simple names of red, yellow, green, blue, black, teal, purple, and whatever those named ones are. Or you can just designate it simply through a hex color. And then we could even put in a line width. And then we could specify a size in pixels. finish with our closed path. And then we have a green circle going all the way around. If we don't want to have it a full closed one, we can see, and we start our measuring at kind of the right hand middle of the circle. So that is our measuring point, is right at that right hand middle of the circle. That's where it begins. So I said go down 15 degrees and then wrap around to 360. That gave me that circle. So that's the unit of measure. So if you want 0, 0 is starting. 0 starts right there. That's 0, and then it loops around. Let's save that though, so we can't see. And if we end this one short, let's see. So this is where our circle starts, and we are going in a clockwise manner by putting this 5th parameter on of false. So I would encourage the math.pi divided by 180 times degrees if you don't want to think in terms of radians. So if radians hurt your head, go for it. If radians make you happy, you know, then you can put it in radians. No, I don't have to do extra math because you're awesome. So to add in a fill color to this arc that has been drawn, and now I'm going to make it a full circle again. Actually, I will make it less than a circle just for fun. But we use context.fill. That fill is a built-in function to the Canvas API. Thus, we're calling it using the parentheses here. So it's a function call, but it stroke, fill, close path, begin path, fill rect, all of these things are built into the Canvas API. So they're already there. We didn't have to define them. Right, you can see there is my circle being filled. And it's still using the same transparent color because that was the previous fill style that was selected in my document. So the question has come up, how do we draw a second circle? How do we get it to show up? We can't. So I have now added in a second statement arc. I've added in a second stroke. So it draws it. Now if I wander over to the browser and look at it, we will notice that it does come up. I'm going to switch back to console so I have no error messages. But it went from the end of my circle and then continued over to the next circle. So with this, we're going to have to relocate or move our pen. So the way to think about doing this is when you're drawing with lines, it's like you've put your pencil down on the paper, and it will stay in the paper for everything you draw unless you issue a move to command, which means pick up the pencil, move it to a new location, then start drawing at that point. Make this one a little bit smaller first. Going to move it out so we can see. So there it is. And if I want to change my line weight at that point, so we can see that after we leave the primary circle where my line weight was 20, then it lowers down to 10, and then it moves over to that new circle. If I want to actually move to it, move to, then I can say the point I'm trying to go to is going to be 50 plus 50 as my starting point, the starting point that it draws the circle. And then my y will be, so the first number is the x position plus the radius. The next number is the Y position, remembering that circles start drawing from the center to the right point. Now I can draw a second circle. So this 100 value is my x plus radius. So if I wanted to, I'll change x to 80 and 50, so it would be 80 plus 50. 80 plus 50, so it's my x plus radius. And I'll change the y here to a different number so we're clear which number is which. X, y, radius, x plus radius, and y. That is the location that we move our pen to. We'll make this one not a full circle so we can see. So we started drawing, then we move to this point here, and then continue drawing the next circle. So to have multiple objects, different strokes, different sizes, we need to then give each object a begin path and a close path, begin path and a close path. Each object gets its own stroke. Each object then is being drawn. We have our stroke styles and widths that are varying. So knowing that, now when we look here, we can draw our separate objects. It's important to pay attention to whether fill or stroke is called first. If I call stroke first, the stroke is centered on the path, so half of the stroke goes inside the object, half of the stroke will be outside the object. So now if I stroke and then fill, we will notice that very clearly is happening with our transparent fill. You will see that the stroke is centered on it. Our next goal is to construct a little rectangle on screen. On this rectangle, we are going to work on animating it and making it move across the stage. Now, I left two in my original document. Now I've left two of the rectangles that I drew on screen. One of those I'm going to be using as my background flood or fill, and I want the one with transparency so we'll be able to kind of see that. So I'm going to fill it with transparent white. I could fill it with transparent, actually I'll use transparent gray on it. So if we fill it with transparent gray, we fill a rectangle 0, 0, and then we fill the rect. We want to do it the canvas width and canvas height, which are 600 by 400. I could hard code those in, or we can't even just do canvas width, canvas height. So that draws a rectangle, canvas width, canvas height. And then I have my other rectangle, but this one I will make much smaller. 50 is too big for animating. Make it 25s. So to prove this is working, I'll save it, open the file up in my browser, and we'll see I have a gray background, I have a blue square. So when we look up here, we have our canvas, we have the context, we've taken care of all of that. So that's kind of the standard business that we will have to do every time we want to work with the canvas. We have to access the canvas object, or we even have to create the canvas object, append child the canvas to the body, and then we need to access its context. So that's a standard part of the procedure that we will always have to go through. After that is where we really have kind of the meat of the program. So I'm going to just put a little division line there, indicating that that part is done. Now, I want to modify this small blue rectangle. So instead of putting it at X and Y, or at 100, 100, I want to put it at an X and a Y location so that it's moving. But if I do that, that means I must have had a variable X equal to something. So I have these variables, X and Y, that I'm going to be working with. So after that, what I want to do is I want to make these X and Y values change. I want them to change on a regular and consistent basis, like the tick of a clock, the frames of a movie. So if we think in terms of frame rate, if we think in terms of time, that's what we're going to be doing. And a very common method for doing it is to access the internal timer object that JavaScript has, which we can use through set timeout or through set interval. For today's example, I will use set interval. And if you look at different examples, you'll find that there are different references of using set interval or using set timeout. There's a new technique that's emerged called Requestanimationframe, which gives a little better performance when it comes to doing this, but it's a slightly more involved process. But the standard conventions, the best ways of doing it, or the easiest ways, Requestanimationframe is the best way to do it. And that also has an added bonus that whenever you have Requestanimationframe running inside Canvas, it will temporarily stop when that particular tab or browser window is no longer the active window, when it loses focus. So you switch to a new tab, or if you switch to a different program so it's no longer in focus, it stops running, which is good, because otherwise, if it keeps running in the background the whole time, that's where, if you're on a mobile device or a laptop, you will find that the battery gets torched. Suddenly your machine gets really hot, and you're like, whoa, what's going on? So Requestanimationframe is the modern alternative for it, but it is not supported in all browsers, so it has a few extra issues and implementation things that go with it. We will look at it, but not today. Today we will use the old standard of set interval for constructing our timing object. So right now, what I need to do is define a function. And my function is going to be animate. So with this function, I can just simply say something like x plus equals 1. Now, what we're going to want to do is this animate function is going to be called every tick of time duration that we specify. So we want to change our x every tick of the clock, and then we will want to call all of our draw commands. So every tick of the clock, we can flood the background, change the color back to our solid rectangle color, draw our rectangle, and then we can update our position of our x. Now, if I save this and go and preview this, we will see that now our canvas is empty, our object is no longer there, and we would think that there must be much sadness in the world and unhappiness because it has ceased to work. But the thing to remember is that it ceased to work because we never called it. So we need to call it, and the way that we can do that is we can just simply say set interval, and now we get to, at this point, specify what function we want called and how frequently we want it called. And our unit of measure is going to be milliseconds. So we can, if we want something to, we could just start out at 100 milliseconds. If we just said 1,000, that means it would call this function once per second. So if we said 100, we're at 10 times per second. If we go down to about 33, then that starts to give us a pretty wicked frame rate, so we get a nice amount. You can decide what your amount is. Set interval, we'll now call that. If we ever want set interval to stop, we need to issue a clear interval command. So if we're building a canvas and we want some control over start and stop, either we have to program that in or we have to put buttons and then write the scripting that when I push on a button it stops the interval, sets the interval, and work that like a play stop button or something along those lines. And now if I load this, you will see that my little box is indeed animating very slowly, but he is animating across the screen. He's animating very slowly because he's animating 1 pixel per tick of the timer.
It's only bad when some days you don't suck.
So I'm going to set my speed X. Now, I mentioned that you could do a random. So if I want to have a random amount this moves, what we end up choosing is math.random, and then we say times. Math.random gives us a number between 0 and 1. We take that number, multiply it by twice as much as we want it to possibly be. So if I want to be able to have my speed X be somewhere between -5 and 5, I'm going to multiply this by 10 and then subtract 5 from it. And that gives me a range between -5 and 5. Because if random gives me a number 0 to 1, times that by 10, I get 0 to 10, subtract 5, -5 to 5. Life is good. And then math.random times 10 minus 5. So speed X, speed Y. And then we can just, my X is adjusted by speed X. Speed Y. So if I save that, run it, refresh the page, and each time I refresh the page, I'll see that it's moving in a new direction. The only problem now is once it hits an edge of the screen, it keeps on going forever. So that's not very good.
Sometimes that's good.
And if I want to see more trails, I'm going to modify the transparency of my background fill so I get a longer trail with it because I just think that looks cool. But right now it's running off screen, so we need to put in some boundary checking. So I need to check my boundaries and find out if I have hit the edge. If so, I need to invert speed X or invert speed Y. So a simple conditional statement that we can factor in. If X is less than 0 or X is greater than speed X minus, and the minus here is going to be the width of the object, which is 25. Otherwise, it would be, the object would have to go all the way off screen before it kicks this in, instead of just hitting the wall. And we take speed X and multiply it by -1. So our standard inversion of the speed. So as long as we're not doing vector operations where we're using sine, cosines, and moving on angled trajectories and all of that more complex trigonometry, the basic method of hitting the walls, reversing our speed X or our speed Y is going to be enough to generate that reversal. So the Y one will be the same. And oh, sorry, this isn't speed. This is not speedx. It's the canvas.width. Sorry, my bad. Minus 25 and canvas.height. So when x is less than 0 or x is greater than the width of the canvas minus the width of the object, and then same thing for y and height, then we invert the speed values. That will allow the object to now bounce around happily and content in my canvas. And we can see that it gives us a nice visual response. So this method, we've coded it in, we've put it in directly, works really well for a single object. If we want to have multiple objects bouncing around on screen, it's going to require building a object class or constructor or prototype object that then has its own x, y, speed x, speed y values, and then we animate that object independently using draw and update commands, which if you apply the object lessons from the previous 2 class periods plus what we've covered today, it's possible to generate that. So working with the basic objects. So in this case, if I were to have a box, we create our object, and when we're creating an object, the object should be labeled with when it's going to be an object constructor. So it's not just a single variable object constructor, and we're making instances or kind of child objects of this. So this is our prototype master, our template. We capitalize it, so that's why it's capital B box. And then set its properties. If we set the properties of the object, we're going to say this.x, this.y. So everything is prefaced with the word this, and then we can have methods or functions associated with the object. Now we did have the discussion previously that a better course of action would be to assign the functions to the prototype of the object, so we're not making new copies of the function as additional objects for every object we construct. But for what we're doing, we're not going to see enough of a performance hit that it matters. So right now, this is an acceptable way of doing it. So this is pretty similar to what we just had in the previous file. If we look here, we're updating the position, checking, see if we've hit the boundaries, and then rendering the object. Now, update the object, draw the object. So we have 2 commands or methods that this function knows. When I make a new box, I made a bunch of boxes, so I stuck them into an array, and then loop through, set interval, same as before, and then that loops through the array, and then it tells each object to update or draw. So looking at this, we'll see that a couple differences. So this is also where the script is at the top using the unloaded init. So the context and canvas were not accessed until after the document was loaded, so it's wrapped in the init function as we've done in some of our other projects versus putting the script at the bottom of the document. The only real global variable here is boxes, which is a little bit different than here where we ended up needing an x and a y and a speed x and a speed y. Now those values are part of the box object itself instead of being part of the main kind of global, it's referred to as the global namespace, the global document. So it's a little bit cleaner because now once I have one box, I can make 100 boxes, I can make 1,000 boxes. If we modify the size of the boxes here a little bit, I'm going to make them smaller so we can put more on screen. and have it look good. I'll knock it down to 10. And as you can see, I have these numbers hard-coded in there. Again, it would be better if I were referencing variables, width and height of the object or the box. That way I could just change it once and it would affect it everywhere, but that's all right. It works for now. They're randomly appearing on screen. They're a little bit smaller. And now instead of 50 boxes, we'll say 500 boxes. And it comes to life.
Whoa.